Okay, we say nest while list and the test applying. Wait a minute. Does nest while I see. Okay, so it's test 1t. Nest while list test, then 1, then t. So the test is length of hash less than max, I claim.
Wouldn't it be better to put flatten in there?
Why do we need flatten? That's the length. That's the number of items.
Because there's some nesting in.
There isn't. Not at this level.
Oh, okay.
This level to the result. Okay, so let's say, for example, we have, let's do this one here. Max, and let's say max is 10, for example.
Okay.
We need to do something here where I mean, we could just use throw in the main thing.
Oh, I'm thinking if you do length flatten, you could do something like 1,000, and then you could see a whole bunch of different results here.
No. What are you saying? Look, this is saying if it ever gets more than 10 items, look, if it ever gets more than 5 items, I pretty much guarantee this is going to not be the same. That's really weird.
We're wanting to eliminate the none cases, but they're not getting eliminated.
Yeah, I know, but the none cases, it's growing big.
And those are the ones we want to get rid of, right?
Yeah, but hold on. Maybe they're not growing big. Maybe they're not. What the none cases? No. Wait a minute. The way I'm getting this none. Yeah, find lifetime isn't doing the right thing here. Because find lifetime, yeah, you see, find lifetime, okay, so look, this should say confirm test. Confirm, what is it? Confirm by hash, length of hash equals t, I think. Maybe it's t plus 1. And then we say enclose here. Well, we can just do that. My God, what's it doing? Okay. I think I was off by 1 here. What? Oh, come on. Okay, this is not perhaps the best way to do it. Maybe the best way to do it is just to put this into that function there. Okay, let's just do the following. So what's happening is this is an incomplete length of object. That's the point. In here, okay, let's build a big function here that just says test TMs. Okay, and then this is going to be basically S blank, K blank, T blank, max blank. Okay, so find lifetime. There's going to be a catch outside that, and it's going to say okay, so now I'm going to write this explicitly. Okay, hold on. Let's just, we got to get a function of rule. Okay, so please pay attention.
Mm-hmm.
Inits is this.
Right. I'm going to say you did it wrong just so you can prove me wrong.
Shush, just a second. Okay, so then what I want to say is at this, if length of hash is greater than max, throw too big, for example. Otherwise hash, apply that to this, apply that to the union. Don't think I need those parens, but let's put them in anyway. Okay, this is SK, oops, P. Okay, hold on. The function of the rule. Okay, find lifetime. Okay, nest while, nest list, that wants to be. Okay, hold on. That's the function that we're nesting. Over this. The find lifetime goes there. The rule goes there. We removed that. And I think we're good. Oops. Function. That should be closing there. What's the closing? That's closing for the catch. I wonder if that's right. Okay, so let's see what happens if I say test TMs. This was 2, 2, 2, 5, 10. Oh, okay.
And I was wrong. You got it right on.
Yeah. It's all right. Okay, so some of those are too big. All right, so we just have to decide how big the too big thing is.
Mm-hmm.
All right, so let's go down here. That was just a check. That's irrelevant. That one's irrelevant. So here we can say test TMs, and that was the case 2, 2, 2, let's say 10, and let's say 10 to the 5. Okay, boom, we're good. Okay, so now we'll say test TMs 2, 2, 3. Let's go a bit bigger. Well, let's say 12, 10 to the 5. What the heck? Why is this going so slowly?
Good question. Maybe there is nesting with the test.
What do you mean?
It's basically evaluating things in a binomial fashion. Every time it does another step, it's doing the test, and the test is redoing everything again.
No. Let's not look at the test. Why is this so slow?
It sped up all of a sudden.
It did, right. Because that's... See, I think what might have happened there... Okay, same result as before.
Try rerunning that test with like 100 instead of 10 to the 5.
Yeah, I know. I'm going to see what that does. Because it may be that it got big.
Or even something smaller like 20.
Why are those slow? Oh, now it suddenly jumped.
It's not nearly as slow as before. It jumped faster.
Yeah, but why is this... Why is it now so damn slow?
Is the parallel sending the entire job to everything?
No, but it does the same thing in all cases. You look back at what it's doing. Okay. I have no idea why this would be slow. I have no idea. what the heck is going on? And why would it be slower if there's... Oh, no, I hit... Okay, so how many too bigs are there here?
Not very many.
So none means...
Slow growth.
No. None means it never stopped growing, right? What it's doing is it's simply measuring whether the last element is bigger than the last but one element.
Mm-hmm.
Okay? But why would this be slow? What the heck is it doing that would make it slow? Hold on. Find lifetime. I mean, I don't think it just computes this first. I just don't understand why this would be slow. I mean, it just gets out of there. If it's larger than max, it just gets out of there.
What happens if we take off the parallel map?
It'll take forever.
My prediction is it'll take the same amount of time.
It won't. I know how this works. That's not a thing. Well, here, I'll do one little rewrite here, which I can't imagine will make any difference. All right, let's try this one here.
Oh, that seems a lot faster.
Really
Hi
weird.
there. Just wanted to say that I'm ready with all of the needed items when you are, Stephen.
Okay. Well, I don't understand why this was faster, but let's just assume let's just take it and not worry about it.
Mm-hmm.
Okay, so this now gives us... Okay, so this is a res 3. Is this, and we can recompute it perfectly happily. And that's res 2 there. Okay. Okay. 2, 2, 3. All right, now we know there are no too bigs there. Counts of res 3. Okay. That's what we had before.
Now, for the next case, there were 2 cases that halted on 7. Have you actually looked at those rules?
I have. They're not very interesting.
Okay.
They don't, in fact, halt. They just get into a loop in the multi-way graph.
Oh, okay.
I can remove that. That's the 3 case. Okay, so the res 4 case. Let's just use 14 because it'll probably be not a problem. So this is now sending the data to the parallel kernels.
So you could probably look at Mano's items while you're waiting on this.
Hold on. Why is this not working? Oh, there we go. I don't know why it's slowing down there.
Those are the difficult cases.
Yes, obviously, but I don't know why the difficult ones there. Oh wow, there was one that was too big.
Huh. We should probably find out where that one was.
I don't think it'll be anything interesting.
Right, but every time there's anything unique, I always want to take a look.
Well, all the same. See?
Mm-hmm. Mm-hmm.
Now we could probably get rid of those cases if we care. Do we care?
Yeah, I think if we go higher, we care.
No, but we're going to go. Look, we don't care because we're going to get back a few too bigs, and they're just going to be who cares.
Right. Okay.
Okay. Wait a minute, this was not the best way to do it. There's a better way to do it down here. And that was 4. Okay, so I managed to get to 6.
Right.
Which had only
I do notice there's a 6, 7, 8 for the longest with this series.
well, actually, there's no 8 in the case of 6 there.
Okay. I thought you just showed one that got to 8.
No, these are the ones that get to 7.
I see.
And that is pretty weird, the way that it gets to 7.
No, okay.
I mean, actually, it's kind of interesting. I should probably capture that one. Well, we can probably get a few others. I mean, all right, let's look at Mano's thing. I think, okay, go ahead. Mano, where's your thing? And then I need to get to writing some stuff. Go ahead. What were you going to show? Actually, I want to show this one here. Hold on 1 second here. Oh, for goodness sake. One thing I really need is this TM applies states graph. I need separately the time steps and the size of the thing. I don't know, do you get what I'm saying? Hello, Mano.
No, she dropped out for some reason. There's only 2 of us here.
Okay. Okay. Well, this was the case of 6 of these, and I think the one case, so we could consider doing this was a way of submitting a batch job. Again, requires breaking this thing up again. Okay, let's do this. Environment, function rule, over delete cases. And then provider settings, etc. I think that's right. So then what we should be able to do so this would be, I mean, we could try and do the case of 7 job env 227 T. Let's go like, I don't know, what do you want to do? 14 steps. And max, let's again do 10 to the 5.
Okay.
SK, I don't mean that. I mean 227, whatever. Okay, then this becomes job 7. Don't think anything's going to blow up horribly here. So this is binomial of the 2-2 thing. How big is the 2-2 thing?
I don't remember.
Well, it's length of TM rule cases 2-2, 32.
Right.
227. That's not that bad.
What was 32.6? Right, not too bad.
All right, so I think we're going to be able to do this puppy. Okay, ready to roll?
Mm-hmm.
Maybe we should do a smaller case just to check. I think this is going to be right because I don't think this is any different from what I was doing before. All right, let's go do it.
Okay. And that's going to Amazon?
Yeah. Somewhere in South America, you know. I'm joking. I'm guessing it's taking time on right now is computing the 3 million cases of the rule.
Mm-hmm. Now, one thing about that combinator, I would argue that's the first centrosine busy Weaver that's been found in 5 years.
Oh, well, you should tell people about it, Ed. Figure out.
I have.
Okay.
But you've got a bigger reach. That's why I'm trying to convince you to promote your own rule there. because it's really hard to find a new interesting Busy Beaver example, and that's kind of, it's a unique case and a unique system. It's much larger than anything we expected, and I don't think anybody's going to beat it.
Yeah, right. Well, it's good. Yeah, maybe we should. Well, we should tell the guy who has the Busy Beaver page about it. Did you send him stuff?
That would probably be a good idea. I'll what is
Why
it?
don't you
The
just-
Radizic's brother. It's a father-son team. So, yeah, I'll contact them.
Okay. Okay. So what's happening here? So this is looks like it's going to be at the limit of what we can do here. 7 case. I don't know why it's taking so long. I don't know why it's. I mean, I don't know whether it has to send all this data. Did Mano rejoin us?
I've got an unstable connection.
Okay. As opposed to an unstable dog.
Okay, now my system's back in. My dog is calm.
Yeah, you really don't want an unstable dog and an unstable connection. Okay, well, any sign of Mano? Yeah. What's going on there?
She could also have an unstable connection.
Everybody could go unstable. Like, okay, well, let's see. This is going to run here. Okay, meanwhile, shoot, this should just run asynchronously, and then it'll just go off and do its thing for a few hours.
Mm-hmm.
And okay, is there any other case we think we can actually reach? Like the 2-2 cases here.
Oh, I think the 3 2s and the 2 3s. At least with a few rules.
Yeah, probably so.
Probably could go up to 4 on each. But we can check the binomial first, do length TM rule cases to.
No, I know, but right now it's running, doing this other thing. I mean, S equals 2k equals 3 cases is kind of interesting because we have that universal rule in the deterministic case. And that rule, if we were to hit it, well, actually, it just wouldn't terminate. God, what the hell is this doing? Serializing input array, okay. Come on. Come on. You just never know inside that data center what will be running next door or even on the same computer. Who's to know?
Hi.
Oh, hello again. Okay. We're waiting for some stuff to get transferred to Amazon here. Okay. What can you go through what you've done here, Manu?
Sure. So if you go into needed items MM, I labeled everything with the date.
Or perhaps Mana should share her screen.
Well, I can start another session, but no, I don't want to do that because. But okay. By the way, Mano, that like these things, like the Turing machines with halt states and things. Did you?
Not all of them, but I can do that. There was one
Okay.
that
You know what I realized? What Ed and I realized is that actually the halt state thing is irrelevant. All we have to do is repeat the last state. So maybe we don't even need that. We just need a little piece of
Okay.
code that does that. Okay. So.
Sure.
Okay.
This is
Did you
the
see the mail from Matthew about this?
yeah. Seems like an ambiguous outcome. What do you think we should do here?
I think we should do what we thought we should do. I mean, before. I don't think Matthew's changed our mind. He's confirmed that we didn't get the outer loop wrong.
Okay. So
Okay.
this is good, right?
I think so. Yeah, but I need to. Oh, okay. Let me just. Okay, here we go. Uploading.
That's the old one.
Well, why are there a bunch of commas here? We don't want a bunch of commas. Wait a second. What are you doing here? So this one, we just say row outside of this. Is that right? With a spacer of 1.
Yeah. Sorry, I missed that.
Okay, let's wait for this thing to upload here. Chunk 3. I'm going to guess we'll only have 8 chunks because those are the master kernels. We have 8 master kernels. Each one can spawn 200 jobs. Yesterday when I ran this, we had about 1,000 cores. Okay, this was the thing that Jesse showed me to do. Okay, this is very, very tiresome watching the...
We can go through the other items if you want.
Okay, all right.
So I think everything was good except the items that are marked updated 125. So the thing with these is
but it's not working, right? Because all kernels are busy right now.
yeah, but basically you get a horizontal scroll bar. I'm wondering if that's okay or
No. Horizontal scroll bar representing what? No, it's absolutely not okay. It couldn't possibly work. I mean, it's got to be. I don't understand. What are you saying here?
the content itself can shrink like the 3D graph, but like the animate around it seems to be like not shrinkable past a certain size. So if you want these to exist on a row,
I don't understand. Okay, fine. We'll have to look at it once this comes back.
okay.
Come on. How big is this thing? Must be many gigabytes. Okay. Hopefully there's no further process that needs to go on here. Come on. Why is chunk 18? Is that thing faking us? Is that chunk 19? I think that's a bug. Okay, just a minute. Okay, let's just check the job status of job 7.
Sorry, I'm back. I had to get rid of an opossum my dog brought in.
Ed, you know, I'm collecting these bizarre. Okay, runnable. Okay, so nothing's running yet. Okay.
Bizarre pet stories from employees.
Yeah, something like that. I just have this urge to just try one of these. So that would be 3, 2, 2. Let's just make that 10 to the 4. And let's call that res S3 K2 P2.
Let's find out how big it is first.
Well, would you like to? Okay, so TM.
We could probably just do a little size function pretty quickly.
Oh, it's 72 squared.
Right.
Which is not that bad. It's very civilized. So civilized, it just came right back. How can that be? Okay, well, let's say max of percent. This feels very powerful that this thing is actually like displaying in real time all of these computers doing things for us.
Yep.
Okay, so now let's take a look at the next case up, because that one came back just instantaneously. That's perfectly reasonable too.
Mm-hmm.
All right, let's just see if that comes up with anything interesting. I don't know why it's taking so long to initialize here. That's really weird. 323. Three, 2, 3, right? I don't know.
That seems correct.
Let's, by the way, let's just stick this in the corner of our screen. Oh my. That dynamic gave a different result. All right, so that's what we're... What the hell is that? Remote batch submit progress. Oh no. Okay, Jesse, help. Okay. Definitely a bit unexciting, but let's see if we can say, let's just do accounts this.
No, that's not too bad.
Well, but let's see if this one.
Do the
Let's get the 6s. Let's just get all the 6s.
and do the same thing on the other one you ran.
Yeah, I understand. What the hell is this? Okay, just a minute. Okay, now with these ones, we need to make the TM applies graph, I think, for these. Wait a minute. I bet that is because this TM applies graph assumes S equals K equals 2. Mano, could you check that?
Say that one more time, please.
TM applies graph, does it assume S equals K equals 2? I gotta get on with some other stuff in a minute. I don't think we're gonna get anything that exciting out of this.
Well, it basically just uses the first rule that's applied.
To do what?
To basically it like extrapolates S and K from that first rule.
I don't understand how it can possibly do that from the first rule. How can it do that? How does it know? I don't understand that.
Well, in my version of multi-way Turing machine, there's an option to supply S and K. So
Okay, how about you tell us what the let me send you these and you tell us what, and you give me the code that
what's the goal here?
to make these pictures. TM applies graph pictures from those Turing machines.
Okay.
Okay, those are those machines. Okay. I guess we should probably check this case just in case it's really exciting. And then we got to stop with these.
Okay.
S2, K3, S2, K3. Thrilling. S2, K3. All right. K3, S2, K3. Okay, let's see, how did that compare? 4, 4, 348. Okay, so they're just different random numbers here. One more.
You could also risk the 3-3.
How big is 3, 3?
I don't know.
Well, I'll do the thing to compute.
Actually, it's not going to be able to interact with itself unless we give it enough rules. And if we give it too many rules, then it'll be way too big. So yeah, I don't think 3-3 is something we can look at.
3, 2. No, 2, 3. Yeah, are these going to be able to? Well, okay. 2, 3. Oh, look at that. We're running half those. Oh, look at that. 100 have succeeded already.
Oh, that's good.
So 100 jobs are fully finished. Some of these animals will have a long tail, however, because we didn't.
And this new job is running fast.
Except for the fact that it's got these really random.
Are these TM implies graphs supposed to halt quickly?
Yes.
Okay. So that should work. The only difference is that it uses my multi-way Turing machine instead of the resource function.
Just a minute. So what was saying? Oh, wait a minute. Okay, you're giving me a new TM applies graph. Okay, so should I replace the other TM applies graph with this?
Yeah, you could. It shouldn't make a difference.
Okay, well maybe we'll do that in a moment. Okay, so then this here is we'll say TM why doesn't this work to just copy that? It copies the stupid thing with an equal sign. It shouldn't copy it with an equal sign. Didn't work.
You need a parentheses around the hash. Or
Braces,
curly
yeah.
brackets. Yeah.
Okay, you know what? I'm going to send something to the user assistance team. Okay. I have never, in all these years, I've never really thought to do this. I've always kind of ended up having to try and find the little tiny letters that are there.
It's a good idea.
Yes. Always good to modernize. These are thoroughly boring. These are all deterministic. As Ed is kind of suggesting, these things don't quite yet get at the maximal size, right? They are not yet. Do you understand what I'm saying? They're not yet. They're not non-deterministic.
Right.
Here, I suspect there'll be non-deterministic ones. Except I'm wrong.
I'll be back in 5 minutes.
Okay.
It took me less time than that to get an opossum out of my house.
Ed, that's very exotic.
Oh, it actually happens all the time.
Okay, it must be a favorite opossum hangout. Okay, anyway, those were not useful. Okay, so let's go. Wow. These are extremely non-useful.
Yes.
It may be obvious that the things aren't. Bluff. Well, let's try the fives in that case.
Oh, we should maybe do the non-deterministic test as an earlier step in weeding these out.
Yeah, we could do that. Well, these are totally boring. But I think that's because there are just too many cases in the rule. You have to feed in more stuff before you can.
Right. Mm-hmm.
Right, we'd have to have them. We could do a random sampling of. I don't think it's going to be very useful. I think the fraction is pretty small. All right, something for somebody else to do.
Yes.
I mean, let's leave it. Let's just leave it. Let me make a note of this. Let me, and then my list of projects here. Hold on. (2021) student projects. S equals 3, K equals 2. All right. Boy, we're almost getting, how do I have this thing? We're almost at the end of that.
Right.
In which case we can, because then we will say job 7, valuation results. That may be absolutely huge as well.
Well, it's 3 million results, so.
Yeah, 3 million numbers, which is not so bad.
But a count would be good to do.
I know, but first let's get okay, it's not ready yet. Okay, we should let's I need to really work on some other stuff here. So I need to do something else here, which is I need 2 things here. Where is it? Yes. I am trying to find I was looking for which ones are causal invariant. Okay, so here I was assessing causal invariance for these.
Right.
Okay. Just okay. So hold on. So this is now so those are causal graphs. But I need to figure out whether these things are causal invariant.
Back.
Hi. Well, sorry, you missed one. Hold on here. So then I need causal invariance checking for these guys. And how do I check that? I just say causal invariant Q for a given Okay, true, false, false, false. I meant there was supposed to be 8 of them. False, true, 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 it says. I think those two are identical. Aren't they just mirror images?
Looks like they probably are.
Why are the causal graphs slightly different? Because the states got placed in different places. In the case where the things are deterministic,
They're actually different. It's a one is a twist of the other. It's not a mirror reflection.
okay. Okay, so the only question here, yeah, it's not so obvious how these things break down into an individual path. So in a case like this, it better be the case that every path through that graph, oh, we have the thing with instances, right? Don't we? Do we have the causal graph instances thing?
Yeah, that is a property.
Okay, so if I say here, it's going to be some absurd number of, oh God. There's some absurd number of graphs. Also, if I take the last one of these, and then I say, thrilling, at least they're all the same. And too early to tell on those. I never can do much with causal graph instances because it depends on the foliation that you're using. All right, so up here, is it the case that a deterministic one of these can never be what will it do in terms of causal invariance if it's deterministic? Oops, there's none of those that are deterministic. So
Isn't it trivially causal invariant because it never branches?
yes, it is. Okay, so now in here, so if I say multi-way Turing and I just say of these causal invariant Q, what? Oh, that was a 1, 2. Okay, so this is going to tell me what fraction of these are causal invariant, hopefully. That's a bit bizarre. What happens if I say t equals 5? Huh. So that means that of these, there are only 2 that are not causal invariant? Oh, wait a second. I said test deterministic here. Well, which 2 are not causal invariant? That's really weird. Um, why would that not be causal invariant? If I want to put, okay, this comma 5 or something. What does the causal invariance checker do with a puppy like that?
Oh, this is basically one of the cyclic ones. So if you used, the cyclic causal invariant Q, then it would return true. You should check the other case though.
Well, wait a minute. What do you mean by cyclic? That's cyclic in time. You see what I'm saying? That's its multi-way graph. Yeah. So
Yeah. For some reason, that'll show up as an unresolved branch pair. I'm not sure exactly how multi-way system calculates those, but
you should make a note of that because I think that's sort of a potential bug in multi-way system. Okay.
okay.
Here, I'll put that in the chat. Since we're trying to make a final version of multi-way system, we should get these right.
Right.
Not completely obvious what it should do for those. Okay, let's do the other case here because that is sort of a confusing case. Okay, that's more like it. So in that case, I might make a table of these. Let me just check that it doesn't change with t equals 5. Nope, good. Okay. So that's that. So that's the number that are causal invariant with the 2. Actually, I'm just going to, for completeness, how many with a 1? None, right? Oh, there are no non-deterministic ones in that case. There's one solitary holdout up there. Oh, why is it so comparatively slow? Wow. Is there any way to compute to use your new causal invariance checker to do this any faster?
I doubt it'll be faster. It's actually pretty slow because it checks basically all of the vertex out component for each vertex.
Okay. Let me just see something here. Most interesting. I might like to get a table of how many causal invariant ones there are, although for that I really have to be more reliable about what. Let's just see what happens if I were to say t equals 3. See that, well, t equals 3, yeah. These weird batch progress submit things, just really weird. Okay. Let's just try t equals 4 now. Just to check. I think if it became, Mano, do you see whether if it stabilizes at some t value, can it ever change? If two t values are the same, can they ever be different later?
How?
No, I'm asking. I don't think they can be. I think if it stabilizes and it's causal invariant, it means everything merged, right?
Yeah. I mean, I guess at later steps, something that is causal invariant at one point can branch out again.
I guess because the tape could have other things on it.
Yeah.
Okay. We need to go through your stuff. So after it finishes this and I get one piece of chocolate, we'll go through your stuff. Hold on one second.
Okay.
Sorry about that. That's disappointing that we're probably going to have to run the t equals 6 case. Okay. All right, let's go through these.
Okay.
Okay, this one first. That's here, right? And this is the correct ordering you claim.
Yeah, but we need to do the row spacer thing. That works.
Okay. Okay.
That was a weird sounding piece of chocolate.
It's an apple. Okay. Now, all right, we're going to have to work on these animators. I have a question how they go in the blog post, okay? So it's kind of a detailed question for Jessica, I think.
Okay.
Where do those go?
In this section.
What a mess. What the hell happened there?
Not sure.
Okay, do I need any of this?
Wait, that's not the same thing. I think it's further down.
Okay, well, what the hell happened here?
I don't know, but if you rerun it, it should be fine. I didn't have problems with it today.
Well, it turns out it isn't fine.
Can you try the version that's in my notebook? It's number 34.
It's broken. Conic Hole Region 3D box.
Yeah,
I'll tell you
I don't know
what
happened.
Let's not put animators in. Let's remove the animator from here, okay? And you should give Jessica the animated version. Do you get what I'm saying?
Yeah, I can give her the animated version.
What value of theta? Shall we say just with theta equals pi over 4? Okay, that was broken. Is that because we changed TM applies graph?
Yeah, possibly.
Yeah, so let's be careful with that. Okay, so this is something else, which is...
My version has the padding fixed, and we only wanted the top one with the rails.
Okay. Well, so this is fixed, but let me do that. Okay. Oh, that's okay. Theta equals pi over 2. Okay, fine. All right, so this will be you'll make that into an animated GIF for Jessica, if we
Okay.
can. Okay, maybe we'll have it like this, and you press something to get the animated GIF.
Okay.
Okay. All right. So which was the next one? What's this one here? 35. So that's okay. Let's simply just run yours here. Nice. Where's this then? Hold on.
They're out of order in the post because they were added at different points.
Okay. Okay. Right, what's next here? Well, should I go through your, hold on. So did I get this one? Where's that one?
Yeah, I think you added it. It's closer to the top.
No, I don't think I did add it. I didn't touch it. It can't be close to the top. It goes
Oh, right. It's in this section. It's this. Yeah, I tried making the graphs smaller, but it looks like the
All right,
the
let's
animate
forget
box.
about the animation.
Okay.
Let's again make them into animated GIFs for the post. Okay, but let's not animate them here.
Okay.
Make sense?
Yeah.
Okay, what's this one? That one is a non-animated one. Where is that one going? Where does this one go?
I think it's in like the section after this.
Oh, it's there.
Yeah. So instead of doing frames, I thought it would be useful to have the boxes here,
It is
just
useful.
because.
It is useful.
Okay.
This looks good.
And then 29 just above, I did a similar thing, but I just I need to ask Charles about those last two and why the edges are so thick.
Why don't you set an edge weight explicitly? Okay, and you've also got only 3 across, and we need 4 across.
Okay.
Well, you
Yeah,
got partition comma 3. Let's partition comma 4.
I did try setting an edge weight explicitly, but it didn't make a difference.
And that box is cut off there. I'm going to hack this for a second. Okay. Actually, it's not that bad. Really not that bad. This is not bad at all,
That's good.
apart from the edge weights.
Yeah.
Honestly, it'd be nice to have these heavy edge weights for all of them.
Yeah, I'm really not sure why they're there for those last two, because
Who knows? It's some kind of Charles voodoo thing. Okay, where's this now? Is that like
it might be easier to just go in order with what's in the post.
well, do you know where everything is then? I think
I've just been matching up the numbers.
okay, 33. Make sure the grid doesn't mess up. I don't understand that.
It was doing a weird thing where all of the different items were scrunched together and cut off.
Okay, but you fixed that.
Yeah.
Okay. Looking good. Okay. Cleanup diagram. 24. Great. Okay. $25. What about multi-edges?
This doesn't have multi-edges.
Good. Then we don't have to worry about anything.
Yeah. Oh, Jess did ask, so for the archive version, we want 3 perspectives of each like animated multi-space visual, right?
Maybe not bother. I think we shouldn't bother. I think what you should do instead is have the post allow you to click on it and animate it.
Okay.
We should just have one thing.
Okay.
Okay, so this one we should just rotate to that angle and make it fixed.
Okay.
Oh boy. Okay, is there a simpler way to say this?
I think the crux of it is in the last 2 sentences.
Okay, why is the branch-like direction? What is the weaving again?
It's where basically the Turing machine can take this alternate path, but it gets pulled back to some, like, I don't know whether you can call it an attractor really, but This is why I had like this distinction between the highway, which is like the fastest path through the system, and then like the byways that are being weaved.
And what are you saying? Try it again. Right.
Yeah, so with more steps, the stuff at the
see.
top basically gets more complicated.
Okay. I think it's sufficient to just say that.
Yeah.
We'll leave it as an exercise for the reader why that happens. um, okay. Good explanation, though. 22.
I can redo this with the single perspective and take care of the GIFs.
Okay, fine. Boy, that looks weird. I mean, in our dark red motif for halted states, don't we want to make these dark red?
Yeah, I can do that. Maybe just like a dark red frame.
Well, or just dark red at the ends. Just put the last thing here, dark red. These look weird. They look kind of out of focus or something.
Maybe
I wonder what would happen if we didn't have any vertical lines at all. Maybe it would look stupid. Go ahead, what were you going to say?
maybe lessen the thickness a little bit.
Yeah, do we have a way to do that?
Mm-hmm. So it's the first one.
This one here.
Mm-hmm.
I'm gonna take off here, and that's gonna cause job 7 to finish instantly.
Okay, thanks, Ed.
All right, bye.
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 These thicknesses are really weird. I mean, I know what's going to happen. For example, if these things are printed out. Well, okay. How did you insert the grayness?
That's in the second block.
Oh, okay, okay. Wonder what would happen. It's actually not totally stupid. That maybe looks better. I wonder what would happen. If we just had the first one be dotted and the second one be default. I don't know what that does. What do we say if we just say directive open close?
You could do automatic.
No, I couldn't.
Okay. I think maybe the ones on the very top and very bottom should not be dotted, but the
Oh,
rest.
no, they have to be consistent, I think.
Okay.
I think this looks okay.
Yeah.
Why did it align itself differently? How do I get? I want to change the size a little bit. How do I do that? What determines? Where is the size determined here? Well,
I think you can pass it as an option to Turing machine plot if you wanted. Do you want to make the
yeah,
dotted lines?
Oh.
Okay.
Oh, yeah. Dotted lines. Where are the dotted lines here? This is the
Yeah,
dotted.
right there, the first one.
I forget what it was, like 0.7 or something.
Mm-hmm.
Was it 0.7 in fact?
Yeah, it was. I remember.
Oh. All right. We just did this one. We just filled this one in.
Yeah,
Oh, no, fixed
but
box, edge weights. Yeah, okay.
this I don't know if you actually still want because we decided against the tailless heads.
Right. That's fine. You know, I want to make these a lot lighter. Okay, did you get this one to work?
And I added 7 more cases
Just for fun.
just for fun.
Are they actually interesting or not?
I honestly can't tell much
Okay.
from looking at them.
I think we should just have one fewer row.
Okay. It's an easy fix. So it's to 20, yeah.
Beautiful. Okay. Okay, busy beavers we need to work on. We'll come to that in a moment. Wait a minute. What happened with this? There should be lines going from one thing to another, like this.
But I mean, like, how would you draw that really? I mean, it would like.
Look, this thing affects this one here. You just draw a line on top of that. See what I'm saying?
So it's because the cell color has changed there that is possible. So we want to show that relationship. So this should basically look exactly like the causal graph.
Well, it won't look exactly like it because it just has a different aspect ratio and it's on top of this. Yeah, it absolutely should look like the causal graph. That's the point. And then you're just lifting the graph off its base and onto this.
Okay. Yeah, I can fix this.
Okay. Mm. That's lovely. Can I get it to scrunch up a bit vertically?
Yes. It might change things
Aspect
a little
ratio
bit.
1.2 there. Well, let's see what happens. Oops. Looks pretty fine to me.
Mhm.
Where does it determine the color of the background color of those things? Is that easily adjustable or is it not?
Yeah, it's in the just event and state rendering functions.
Where? Here?
No, in multi-way Turing machine.
Let's just make a small change to that. Where is that now? So what should I look for here?
Up top. Get yeah. The rendering functions are down at the bottom.
Event rendering function?
Mm-hmm. And then the state graphics thing.
What's this background I want to change? The yellow background there.
I think it's the RGB color.
No, I understand. Let's just try this, okay? Did that change?
I didn't notice.
Hold on. Maybe that's the border. Hold on. Where was that?
Try changing the one on bottom, because I think that might be the like.
Oh, it says background. Oh,
Yeah,
down
but
here.
yeah.
All right, let's try that one there. Oh yeah. I prefer that. It's a bit more intense. Emphasizes the events.
Okay.
I mean, let me see what it looks like in this case. Can I just rerun this here?
I have another version in the notebook.
I think it looks pretty good. Good. Nice. Well done. Okay.
Well-
Bluff.
Yeah, I think the ratios can be tweaked here. I didn't know if you wanted that.
Well, I mean, that definitely doesn't want labeling there.
Okay.
Where is the label box ratios? Well, it might look okay actually actually it might look okay. The box ratios are really arbitrary. So what would we do? We would do, which one is the one axis? Branch like is the one axis. So it'd be 1 to 0.4 to 1. Oh God, look, the bubbles went,
Yeah, they're distorted.
okay, but there's a way to deal with that, which is to multiply each coordinate by something, right? Forget the box ratios, right? If we multiply the coordinates, wouldn't we get the box a different shape?
Yeah, we would. So do you want it to like be more even along all the axes?
Well, I think this is okay. I mean, that's okay. Look, I'll put this in here, but then you can fix this, okay?
Okay. I changed the function that you were using for this, so this shouldn't be a problem anymore.
Which shouldn't be a problem.
Number 31, the graphs having multi-way colors.
Okay, so I think this is already done, right? Oh, what the heck happened there? Did that
If you're using cyclic TMSTG1, then the edge style is already cooked in. You should be good.
Okay. Okay, and so this is already right here.
Mhm.
Should I rerun this just to check?
Good.
Yeah, okay, good. Okay. I think these were okay. Now that one is a rulio graph. Does it have the right edge style here? Yes, edge
Yes.
style is a states graph of that, so that's right. Okay, dandy. Okay. Why is that still a bitmap?
I didn't do this. I think it's in needed items 01.
Okay. Okay, 44.
So I tried some different endpoints and I increased the thickness, but I'm not sure what you meant by pure path character.
Well, look, those shouldn't go like that. That's a mistake, right? That should never happen unless it's going back on itself. It's got to be a path, right?
Okay.
No,
So
no,
there
I
shouldn't
mean,
be any loops.
well, I mean, but it often makes a loop for me because of silliness with, honestly, I think this one is pretty good.
Okay.
So, okay, so then this here, could I just use this one?
Mhm.
But I don't want to change GX at the top there, right? I don't know what
No,
TMN.
that's
Okay, let's talk about the colors here.
sure.
I think that yellow is a little bit, I think it should be, where are the colors here? Do we know?
They are basically just created by a highlight graph.
Yeah, I see, but where are they created here? Highlight graph.
Just as a part of the function itself. I don't specify them anywhere.
Okay. You know what? That looks fine at that size. Time to declare victory for these.
What was that?
I said it's fine. Just make them that size.
Okay.
I think that's fine.
So I just chose an unresolved branch pair and I highlighted it using the branch rail graph coloring. And the source
Where does
vertex is
this
it.
wait a minute, where? I'm totally confused by this.
So you think I should use, so the source vertex is a bit enlarged. And so
Where
there's a,
does it go to next? It goes to here and then goes back to that vertex. Wow, that's weird. And this one goes to here and goes into that vertex. Well, those should be different colors. This should be a different color from this. And you should
okay,
use these same colors as you used up here, and also thickening.
okay.
See what I'm saying?
Mhm.
Is that easy to do here?
I will have to change it around a bit, but I can do it.
Okay. All right. I'm going to put this there for now.
Are the arrowheads large enough or do they have to be increased?
No, they're fine.
Okay.
All right. Now, the one remaining thing here, okay, where's the causal invariance checker for the cyclic case?
It's in Codo 2, the enumeration and characterization section.
Is it cyclic TM invariant Q?
Yeah.
Oh, so this, I was checking the Rulial case here.
Yeah.
Okay, so if I were to go something like this, TM, do I need the 3 there? I don't need the 3 there. You told me I just need 1 there, right?
I think so. I mean, I could be wrong, but I think if you have all of the states generated, then you should only need one step
Okay,
to
so
connect all
let's
of them.
do. Okay. So I wonder what the correspondence is between this and causal invariance in the bulk. All right, let's see. Actually, hope that big job is finished. Oh, for goodness freaking sake. Wait a minute, why is that happening? Is that because we have different conventions for how the rules work in the two cases?
Yeah, I think so.
Oh, for goodness sake. Okay, so what should I do here? Subsets of TM rule cases works in this case here, so why?
Is it with
Oh,
test?
this thing here is wrong. Okay. So that's the cyclic case. And now the non-cyclic case. Is this the right thing? How can this be right? It is right. Well, here. Okay, so that's cyclic and this is non-cyclic. Okay, so let's compare them. They're clearly not the same. 6, 7, 9. Interesting. Okay, let's check your assertion about 1. Well, that's interesting. So, I mean, I guess here, oh, wait a minute. That's not right. Look, you see, that's TM all states 1, 2. Should be 2, 2 there.
Yeah.
Do you understand that?
I mean, you are taking subsets, so
What do you mean?
it could mean that like just not enough of the Rullial space is populated enough to, you know, create cycles.
All right, let's look at 1, 2. All right, let's look at the S equals 1, K equals 2 case. Okay. All right, S equals 1, K equals 2. S equals 1, K equals 2. Doesn't even need to be counted. Interesting. Interesting. Okay. So now let's look at the infinite case. 1, 2, 2. Get it right? Okay, so because we didn't look at all possible initial conditions here, let me just understand what happens if I go to larger sizes here. Okay, and what if I go to more puppies here? How would I do that? I would say TM all states. Well, let's just try 1, 2, 3, for example, here. Okay. I think this is probably very broken. It's probably doing really weird things.
Yeah.
Okay, so this one here, as we go towards the Rullial limit, it's 8. Okay, so the Rullial limit is not going to be that bad. So we can go, so what should happen as we go up here,
We converge on causal invariance.
that's what I'm thinking. Let's just see what happens. Lovely. That's quite lovely.
Great.
I just want to check one thing here, however. I want to check your belief about, well, I want to check that this doesn't affect anything. I have a bad feeling that it might.
Well, it just means there are longer cycles, right?
Yeah. Good. Shoot. Oh my gosh. You know, it's like in chemistry, you heat, constant weight. A total hack, of course, in chemistry. Same thing here. All right, while we're looking at this, well, I just want to make this go. I just want to look at this Busy Beaver section, and then I think we are done, and I just need to write.
Okay.
You know, I'm going to hack this. It's fine. I'm just going to hack this. It's no problem.
Hack what?
This thing about halting Turing machines, it's really not a problem.
Okay. I mean, I did.
I just, what? No, I mean, the thing is, what I want to do here is that I mean, you could help me write this code, that what I did here was I added fake transformations at the end.
So, like.
But in fact, what I want to do is just to replicate the last step. Just keep replicating the last step, okay, like I have here.
Okay.
And actually, if you could do that, it would be great, because then I could just replicate it for a couple of steps after these, and then I'm going to have to resize these things. Then this will have to be probably 2 panels and things, right?
Okay.
Yeah, let's wait for this to finish and then hope it's okay. Oh no, what did it do? Oh, there. Oh, come on. Nah. Oh, this is very annoying. Why is it taking so long? 7, why was that? Oh, because there may be a bunch of cases. Well,
No, I
Okay.
think it's because of the number of like the number of states given by TM all states, because this causal invariance checker has to go through every vertex.
okay, but why is it taking so much longer when it has? Oh, I see. When the rule is bigger, there are more connections at every node.
It's more that like when the tape is bigger, there are that many more possible states, and yeah.
All right, I think we got it though. All right, thank you very much. Oh, you were going to try and do this Turing machine thing. You can. I'm going to go. Do you understand what to do here?
Yeah, I can take care of it, and I assume we'll do this again tomorrow.
Oh, I guess. Yeah, I'm not going to be quite finished today. Yeah, okay,
Okay.
that's fine. All right, thank you very much.
Okay, thank
See
you.
you there. Okay, bye.
See ya.